Hello, everyone. I hope you are doing well and staying safe. Welcome to the AWS Summit Online, and thank you for joining this session. My name is Blaise Pele. I'm a Principal Mobile Specialist at AWS. Today, I'm going to talk to you about how you can leverage AWS AppSync and AWS Amplify to build secure, data-driven solutions for your organization. We'll start by reviewing the current situation and challenges to understand what companies are currently facing into mobile space. We'll also take a look at how mobile users' behavior and expectations have changed over time. Next, I'll provide an overview of AppSync and Amplify. I'll go over how these services and tools allow developers to build differentiated solutions. Then I'll cover some of the security aspects of AWS AppSync. These features allow customers to deploy GraphQL APIs that meet their security requirements. Finally, we'll take a look at how Amplify helps developers focus on data modeling to optimize their development workflow. We'll look at how AppSync helps securely connect multiple data sources and makes them accessible via a single API. So we are seeing more companies adopt mobile-first strategies. This is driven by an increase in more people accessing the internet via their mobile devices. At the same time, we are seeing an increase in the volume of usage, the number of people using mobile services. We are also seeing a shift in the preferences of people on mobile over time. For example, in the US, people are spending more time on their mobile devices than they are watching TV. So this is a shift in trends. Consumers expect that companies cater to their mobile-first behavior, and companies are responding. In 2019, 40% of e-commerce sales were mobile, and by 2025, there will be more than 5 billion mobile internet users globally. That's an increase of more than 1 billion users. So there's definitely a business case there. At the same time, innovation across three themes has created an application development environment that is even more complex. First, there's big data and personalization. Apps are more targeted, leveraging data to create more personalized experiences and recommendations to break through the clutter. Second, customers are interacting with applications using a variety of devices and environments. Apps are cutting across mobile, web, and the Internet of Things, IoT. It's not uncommon to find applications that provide functionality across all these medium. Then there is AI/ML, the advent of AI/ML. Customers are interacting with apps in more ways than just across devices, but also through new interactions, such as voice, bots, and multiple languages. So it's becoming more complicated for companies to stand out. Companies have to keep innovating and iterating quickly just to meet the customer expectations. Now, when we talk about customer expectations, they've steadily risen. This is not really new. It's been going on over the last couple of years. But customers have come to expect that more from their apps. They have limited patience and poor quality, and increasingly, customers are expecting that they should be wowed by their app experiences. So if you look at some of these stats, maybe you'll think about the story a couple of years back about users quitting a video if it doesn't load within a certain amount of time. Well, that's kind of what we're seeing here. And at the end of the day, this creates a really high bar for fundamentals. Your app needs to just work. It needs to work. It needs to be fast. It needs to have a core set of features, offer flexible logins, be secure, and of course, have availability whenever and across any device. These things just need to be there. You're not necessarily going to win points for having these, but they are expected nonetheless. They are just the basics. So executing on these at speed and with quality is key. But even more importantly, freeing yourself to focus on app differentiation is just as paramount. Ultimately, all the inputs we just went over, the mobile growth, the consumer usage trends, the technology innovation, lead to three main requirements when developing a mobile strategy: speed, innovation, and performance. You have to launch quickly, you have to offer something different and new, and it's just got to be highly performant. So it's really important to be able to get started quickly, but you've also got to be able to get to market quickly. This is what users want. and that is what companies need to succeed. This is why we built AWS Amplify and AWS AppSync. AWS Amplify is designed to be the fastest way to develop mobile and web apps that scale. AWS Amplify is a set of tools and services that enable mobile and web developers to build secure, scalable, full-stack applications. Amplify helps you get to market faster with easy-to-use tools and services, which includes UI components, libraries, abstractions, and best practices built into the backend code. So this is great for full-stack developers. Amplify helps you innovate your app with comprehensive tools and services, which support multiple web development frameworks and native development as well. It provides rich features and provides a one-stop shop for developers. Last but not least, Amplify helps you perform at scale because it's built on AWS, which means it's global, reliable, and scalable. It is secure by default. We have designed AWS Amplify so it's a fully featured solution across the app development lifecycle, so at every step of the way. Our goal is to make it quick and easy to incorporate a range of proven services into your application at each stage of your dev cycle. Amplify includes libraries, UI components, and the Amplify CLI that integrates your backend with the most popular frameworks for building native, hybrid, web, and progressive web apps. This includes React Native, React, Angular, Vue, Ionic, other JavaScript frameworks, and we also provide the tools that native developers use to build native apps. Additionally, Amplify offers capabilities to build and host web applications, including end-to-end testing as part of the build process. So let's look at AppSync. AppSync is a managed service that uses GraphQL to make it easy for applications to get exactly the data they need. AWS AppSync simplifies application development by letting you create a flexible API to securely access, manipulate, and combine data from one or more data sources. With AWS AppSync, you create GraphQL APIs that your applications interact with over the internet. While the API endpoints are publicly reachable, they never allow unauthorized access. A method of authorization is always required to access your AppSync API. This ensures that your API stays protected from unauthorized access at all times. AppSync provides 4 different authorization modes to cater to different use case and patterns of approach: API key, Amazon Cognito user pools, and OpenID Connect, and AWS IAM. Let's take a closer look at when and how you would want to use these different authorization modes. The API key. So this mode allows you to define a static API key used to authorize requests. You use a HTTP header X API key. You create a key with an expiration date, and AppSync accepts requests that use the API key while the key exists and has not expired. The API key is a hard-coded value in your application. API keys are recommended for development purposes or use cases where it is safe to provide public access to an API without specific authentication requirements. This can apply when your app provides some type of guest access and users do not need to authenticate to use your services. Applications expected to be long-lived and widely distributed should not use API keys unless you have a use case where all or part of the application will always support guest access. Cognito user pools. This authorization mode leverages Amazon Cognito user pools. After signing in with user pools and receiving JSON Web Tokens, JWT for short, your application uses the tokens to authorize requests with your AppSync API. Information about the user, its group, and specific attributes or claims can be used for granular access control at the AppSync layer. So this is pretty powerful. For instance, you can restrict, read, and or write access to specific types based on the user's identity or group membership. This is a great mode to use when you authenticate users in your app or allow users to access your app using their social identity. You can also exchange Cognito user pools identity tokens for AWS IAM credentials that then allows your app to interact with other AWS services. So this is also a good choice when you need to interact with other AWS services, such as Amazon S3. OpenID Connect. So the OIDC authorization mode is comparable to Amazon Cognito user pool method in that it uses JWT tokens. In this scenario, you configure AppSync with a fully compliant OIDC identity provider as an authorization provider. Upon receiving a request, AppSync validates the access token using the OIDC's IDP's JSON web key set. If the validation is successful, AppSync authorizes the request. This is the right mode to use if you have an existing user directory and you do not plan on interacting with other AWS services from your app. And you can do the same type of granular access control at the AppSync layer that you would do with Amazon Cognito user pool. Last, we have IAM. With the IAM authorization mode, requests are signed using the AWS Signature version 4 signing process, better known as SigV4. AppSync grants access based on the associated permissions. When using this mode, you create an IAM entity, so this can be a user or a role. And you define permission into policies attached to the entity. You can also establish granular access control via the policies that you set up. The IAM authorization mode is a great fit when used with backend systems like Amazon EC2 instances or AWS Lambda functions that can be securely configured with AWS credentials. EC2 instances can be configured with instant profiles, and Lambda functions can be configured with an execution role. These different authorization modes allow you to build an API that allows for different types of access. Additionally, AppSync supports multi-auth configuration on its APIs. This means that different types of systems can access the same API using the appropriate authorization mode. This allows developers to cater to different types of devices, users, and access patterns. Developers can even integrate backend processes to take asynchronous actions on the API. As you see here, we've got a Lambda function accessing the AppSync API. To configure multi-auth, you simply define your API with a default auth mode. This will be the auth mode that is used unless otherwise specified. You can then add additional modes as necessary. You can specify which types and queries are available to each mode. All right, now that we've done that, let's do a deep dive into how to build an actual data-driven secure solution using AppSync and Amplify. If we quickly look at the Amplify CLI, the CLI is one of the components that the Amplify framework offers. You can use the CLI to manage the AWS resources that your front-end application interacts with. The CLI is pretty intuitive and built around use cases, which makes it very simple to use. One of the really powerful features of the CLI is the GraphQL transform. The GraphQL transform provides a simple-to-use abstraction that helps you quickly create backends for your web and mobile apps on AWS. With the GraphQL transform, you define an application's data model using the GraphQL schema definition language, and then the library handles converting your SDL definition into a set of fully descriptive AWS CloudFormation templates that implement your data model. In short, it lets you focus on data modeling and translates your models into a fully functional backend infrastructure. So it's a really powerful tool to use. The GraphQL transform supports a number of directives that allows you to add functionality to your API. You can easily model relationships, add authorization rules, create data sources, and so on. This is done by adding amplified directives in your schema. For example, using the model directive on a type associates the type with a DynamoDB table. It creates the queries, mutations, and subscriptions related to the type. It also creates auto-resolvers needed to interact with the table. So all of that work that you would normally have to do to create the resolvers and define them and set up the business logic can be taken care of by using the model directive when you interact with a DynamoDB table. This way, you get a single source of truth that is well documented and easy to source control. So let's say you want to build an awesome to-do system. We've got a set of requirements from our company. This to-do system allows users to review images. They simply create a to-do associated image with it, and then they're able to review it. A user can create a to-do with a name and an image. What's really important is that users must authenticate to use the app. Thumbnails are generated when an image is uploaded. We want to save onto bandwidth. Users should only be able to modify their own to-dos, but there is an administrator group who should have full access. Additionally, the company has an existing system hosted in their VPC that our application can interact with to retrieve metadata. So let's take a look at what this would actually look like. I'm going to run through a demo to kind of show what happens here. I'm logging in as a user. This is a regular user. As I log in, I'm greeted by a set of to-do images. You see that I've got a couple going on there, and this is my main view that shows me my to-dos. You see that I've got metadata that's been returned by my backend. I can interact with the AppSync API to get label information for my image. This label information is actually coming from Recognition, but it's set up through Amplify, and it knows how to access my files in an S3 bucket that I've set up to hold these images. I can go ahead and delete a to-do if I needed to do that as well. Now let's see how it works when I want to add a new to-do. Create a new to-do with study and review. I go and look up a file. You'll see here that I get the preview, and then I'm going to click add to add it. But real quick, I'm also going to take a look at the WebSocket that we've set up. So what you're seeing here first is that the image is being uploaded to our S3 bucket, and you can see the progress. Now, when the to-do first comes up, you don't see an image. And this is because we don't want to show the original image that is pretty large. We only want to show the thumbnail. So first, we got an onCreate to-do subscription notification. Then we got on update to-do subscription notification. And the thing that you'll see here is that it has a thumbnail and a file. So the thumbnail was generated by a Lambda function who then updated the to-do. I can also go to another view. This is all the to-dos that are in the system, and we're sorting them here by status and date. You can see that these are in progress and were created on June 22nd. I can do another query to get all of the ones that have been completed. And if I wanted to, I could also switch the date to filter on that. Now I go back to the to-dos that are in progress, and I slide down. And there's a couple of to-dos here, the ones that start with admin, that have been created by an admin user. They have not been created by me. When I try to complete this review, you see here that I get an error message. Now, this is not really an error. This is because the to-do is protected. This is not a resource that I owned. So when I've set up this project with Amplify, I specified explicitly that only admin should be able to change to-dos that they don't own. So to show you how an admin would be able to do this, I'm going to sign in with another user in another browser. Sign in, and I get greeted by the same view, but in my own the to-dos that I own, I get a different view. I can delete the to-dos that I have, and so on. Let's see what happens when I go to all to-dos. So if you remember, this is the one that I had created. I don't own this. This user does not own it, but is able to complete it and is able to delete it. So this is a bit of an overview of the system that we want to build. Does a lot of things, interacts with a single API, but interacts with multiple data sources and systems in the backend. So let's here's an overview of the architecture that we would have to put together to support our application. Getting to this point can be fairly complicating depending on how we approach the problem. But let's see how we can approach this easily with AWS Amplify. So if I want to get started with this project, the first thing I'm going to do is initialize our project using Amplify init. Then I'm going to set up off to create a Cognito user pool that our users will use to sign in. We add the API and configure it with Multioff. So we want the API to be accessible via Cognito user pools and from services that are using AWS credentials. At this point, we can push our changes. So we can push all of these changes to the cloud. Again, this is going to create a set of CloudFormation templates that will then deploy all of our backend resources in our AWS account. We can also choose to mock the API locally. This can make it easier for developers to iterate through changes. So by mocking it locally, this will start local API that our application can actually interact with, so we can develop with this local resource at our disposal. Now, that being done, we can start modeling to build our application. Again, data modeling lets us focus on the types, the connection between those types, and how we can interact with the types. So we defined the to-do type in our schema SDL on the left. This is our basic entity that we want to interact with. It's pretty much our whole world when it comes to this application. It's the to-do type. We're going to add the model directive to it. This annotation marks the type will be saved in a DynamoDB table. It also creates all of the mutations, queries, and subscriptions needed to interact with the type. We also want to be able to easily search through our to-dos. DynamoDB is great for key value lookup, but not so much for fuzzy searching. So we need a more appropriate data store for that type of work. As we often say at AWS, pick the best database to solve a specific problem. So we use the searchable directive to mark our to-do type as a type whose data needs to be streamed from a DynamoDB table to an Elasticsearch cluster. This creates an Elasticsearch cluster and a Lambda function and turns on DynamoDB streams on our table. The DynamoDB stream captures the activity on the DynamoDB table in near real time. It triggers the Lambda function, who then replicates the data in Elasticsearch, making it easy searchable. We then have a query that we can use to make easy searches towards our Elasticsearch cluster. Next, we add authorization rules. So we need to do three things here. First, we need to add owner authorization. So the first rule allows for users to create to-dos and limits access to each to-do to the creator. This is done by setting and checking ownership using the owner field. We specify that we want to use a specific claim from our Cognito ID token to identify the owner. In our case, we want to use Cognito sub. By default, this would use the Cognito username, but you can change this for Cognito user pool and for OIDC as well. Second, we add a rule to allow all user pool members to read all to-dos. We're okay with all members reading all to-dos, so we simply add a rule, and we do that by specifying the allowed operation, read. That's what users can do by default. Finally, we add a rule to grant all permissions to all members of the admin group, simply by adding a third rule with groups. So we've done quite a bit here, and we haven't had to leave our schema. How we interact with our model and what we can do with it is all captured here. It's easily understandable. Any changes made to the schema are reflected in our AWS account when we do an Amplify push. There are a couple of views we want to support in our app. We anticipate there will be a lot of to-dos in the system, with multiple owners and in different status. It's not feasible to return all to-dos at once. We would like to support two primary views. One to show users to-dos, and another to show to-dos that are in progress, filtered on the date that when they were created. We can use the key directive to do this. This will allow us to run efficient queries on our DynamoDB table instead of doing scans and filters, which are less efficient and more costly. Let's examine the list to-dos by status and date key. To set up the key, we provide a name, which field should be used to create the key, and we provide an optional query field. This adds a field of that name into query type. We can then use that to query directly. Behind the scenes, this will create a global secondary index with status as the primary key and create that as the range key. This will allow us to query for to-dos based on their status, sort them by their created at date, and if needed, retrieve a subset based on the date as well. For example, here we can fetch all the to-dos that are in status in progress, but only get those that were created in the month of May. So you see 2020-05. We do this by providing the filter on the range key created at. This field is a time scaler that is sortable. The date begins with the year, the month, and the day. It makes it a great type to index on. This is pretty powerful and allows our application to be efficient. So we've done quite a bit with this as well. So let's move on to the next feature. Since this is an image-based system, we need to be able to upload images, and we want to create thumbnails. As I mentioned, creating a thumbnail makes it easier to load images, especially on a poor connection. So we want to be thoughtful of the mobile users that are using the application. This is better. And to do this, we need to introduce storage and add an AWS Lambda function to handle thumbnail creation. We can set up the resources and trigger with Amplify as well. We start with the CLI and the add storage command and walk through the prompts. We give the storage resource a name to identify it within the project. We specify an S3 bucket name and state that only authenticated users should have access. Here again, Amplify is aware that we have an auth resource backed by Cognito user pools. Amplify can limit access to the bucket to users only and creates a structure that allows for granular control of objects. Users can choose to upload files that are available to guest users or that are available but protected and only accessible by other authenticated users. They can also choose to upload images and files that are completely private and only accessible to them. All of this is done through the granular configuration that we do on the permissions to access the bucket. The prompt also guides us to create a new Lambda function that handles S3 triggers. We do so and ask Amplify to grant the function access to our bucket and to our AppSync API. So now, when a file is uploaded to our bucket, a trigger calls our Lambda function, which pulls the file and creates a thumbnail. Some of the stuff that we're doing behind the scene is when we first upload the image, we actually attach metadata to it. So the metadata is going to have information about the owning to do and whether it's an original file, because we don't want to be in a situation where we reprocess thumbnails. Then, when the thumbnail has been created, the function interacts with the AppSync to update the to-do item, which will get reflected into DynamoDB table. Now, don't forget that the update mutation will trigger a subscription at our clients and allow them to immediately reflect the changes and use the thumbnail. So this is what we saw in the application walkthrough earlier. So this is pretty powerful as well, really done with the Amplify CLI. Now, we've created the storage, we've created the Lambda trigger. The Lambda function, however, needs to interact with our AppSync API. So we also need to update our schema to allow requests that have been signed using SigV4 and AWS Credential. Without this, calls from our Lambda function will be denied. We do this easily by adding a new auth rule to our to-do type. This is the fourth rule that we're adding for auth. We allow private access that uses the IAM Authorization mode. We restrict access to only reading and updating. That's really all that's needed here, right, by our Lambda function. And we can always revisit this rule if the use case changes. So maybe later on we're satisfied with what's going on and we want to remove the read, or maybe we want to add some delete functionality. We can come back here and just change what's listed under operations. The other thing that we do is that a to-do is associated with an image and a thumbnail. The image is saved in an S3 bucket, but we need to save the metadata for these images with our to-do into DynamoDB table. So to do this, we add two fields, a file and a thumbnail of type S3 object. So the S3 object contains information about the key, to bucket, and to region, right? We can then use that metadata information to fetch the file from our client. When we create the S3 object, this is actually a special type that Amplify is aware of, and it will create an input that will allow us to easily save the file information with our to-dos. In an Amplify project, it's pretty simple to manage files. The Amplify project is configured with all of the information to access our resources. So uploading a file to an S3 bucket with the Amplify storage library is straightforward. We simply call storage put. When this completes, we can create our to-do with the file information. For example, here I create a to-do that is in progress, belongs to Brice, that's me, and has the file information. Next time I load this to-do, I will have the file information and can call storage get to fetch the file. It's fairly straightforward. One of our requirements is to fetch metadata about the to-do from an existing system in our VPC. We can also do this by using the function directive. This directives allows you to quickly connect Lambda resolvers to an AppSync API. The resolver interacts with the Lambda function in our account that has been provisioned by our infrastructure team. So for this to work, of course, we are using improved VPC networking for our Lambda function. So our Lambda function actually has interacts with an ENI that lives into VPC. And through that can connect to resources in the VPC. So it could interact with a load balancer, ECS or EKS cluster. This is a great way to interact with VPC functionality. So let's look at what happens when we call to query list to-dos by status and date, which we looked at earlier, with a selection set that includes metadata. Remember, the selection set specifies the information that I want to see back. When I run a query, AppSync will take care of resolving each field into selection set, and when required, call to resolver for each specific field. So if we look at the query, the top-level query, the query's resolver is associated with a DynamoDB table and data source. When the query executes, AppSync fetches the to-do data from the DynamoDB table. When it comes time to resolve the metadata field in our selection set, the Lambda resolver will be called to retrieve data from our VPC. This is a great example of AppSync interacting with multiple data sources in a single query. Our client does not need to make multiple calls to different backend systems to get the data it needs. This is really efficient and allows the client to interact with one single API. Finally, we need to identify labels into images we stored in S3 bucket. Having the labels will help the users do their image analysis. So as you saw in the walkthrough, I could simply click a button and in real time interact with the recognition service through the AppSync API. To do this, we use the predictions directive. This is one of my favorite directives because it's pretty cool. The prediction directive allows you to query an orchestration of AI ML services such as Amazon Recognition, Amazon Translate, and Amazon Poly. This is a pretty cool directive that can chain multiple calls to these services. So for example, you could make a call to your AppSync API to identify labels in an image. This is what we did in our situation. But you could then take those labels and have them translated into another language before converting them from text to speech, right? And having them put in our S3 bucket, and then having the S3 bucket key returned to us so that we can grab that file and play it at our client. So that's pretty handy. And we can do all this with a single call. For our use case, we are going to make use of the Amazon Recognition image service to identify labels in our images. We simply add the predictions directive to our identify labels field in our query type, and we specify the list of actions we want to query to take when called. Again, in our case, we only need to identify labels. Amplify will create an HTTP resolver to interact with the Recognition API, as well as a scope down role to access images into S3 bucket. This will allow Recognition to access and analyze the images. Now, we can call identify labels with the key to our image into S3 object, and AppSync will return a list of labels to that application. At this point, we are done. There you have it. We have a whole application that has been configured by working primarily with Amplify, with our schema, where we've used our Amplify directive to build full-blown, full-scale architecture in our AWS account. So thank you very much for joining us today. I hope this was helpful, and I look forward to seeing what you build with AWS Amplify and AppSync.